This course is in discrete mathematics. We are discussing the subject of logic, propositional logic, and today we will discuss quantifiers. So there are two quantifiers that we are familiar with. One of them has the funny look. It is the capital letter E, which is flipped like a mirror on its side, and the other one is the quantifier that looks like the capital letter A, which is flipped on its head. So let's begin with the first one. So the first one it looks like this, like the letter E looking through a mirror. And when we are using this quantifier, we want to say something about this number x that we chose, and we want to say that there exists, this is where the letter E comes from, there exists in the world a number, let's call this number x, and then we can say something about this number. So we don't know how many x's are. Maybe there's only one, maybe there's more, but we know that at least one exists. There is one that is in existence, that whatever we say now about this x would be true. So for example, I can say that there exists a number in the world that if I will add to it the number 2, then I will get the number 7. Well, yes, there is a number in the world that there is existing some number in the world that will satisfy what I just said. For example, if I will choose the number 5 and I will add to it 2, then yes, I will get 7. So there is some number in the world. Exists some number in the world that I can say something about this number, and it will be true. So this is this quantifier, and this is how we write it. The other quantifier that we have, and we write it like the letter A, flipped on its head. Now when we want to say something about the number x that we are choosing, now we can say that actually whatever number in the world that we will choose, what we're going to say now about this number x, it will always apply to whatever number and whichever number we're choosing. So for example, I can say with the confidence that no matter what number I will choose in the world, if I will divide that number by itself, then I will receive the number 1. And this is true for every number in the world. If I will take the number 100 and I will divide it in itself in 100, I will receive 1. And actually, whatever number I will choose, this will be correct, except maybe 0 because I cannot divide it in itself. But this is just an example. Maybe it's not the best one. But what I wanted to show is that when we use this quantifier, we want to say something about x, and x can be any number in the world, and whatever we're going to say about x, it's something about it, its value, its behavior, whatever, it will apply to whichever number we will choose. So these are the two quantifiers that we usually use. Now, until now, I showed you what happens when we're taking just one of the quantifiers by itself. But actually, what we many times see in our classroom is that we are taking two quantifiers and we're putting them one after the other in a couple, in a dyad. So we can see sometimes this kind of phenomenon. So what we see here is twice the quantifier of A flipped on its head. And what does that mean? What does that mean when it comes like that as a couple, as a dual? So what it means is that now I'm talking about two numbers, x and y, and for these two numbers, and I'm going to say something about their relationship with one another, or something about their behavior, or something about those x and y numbers. But what I'm going to, when I write it this way, I'm telling you that I can choose those two numbers from any number in the world that I want. There is no limitation. I can choose any number I wish, and whatever I'm going to say about x and y, and I chose x to be any number I want and chose y to be any number I want, and then I'm going to say something about the relationship of x and y to one another or to other numbers, and this will apply to any two numbers that I will choose in the whole world. For example, there is a law in mathematics that when I'm adding two numbers, one to another, it doesn't matter if I am adding the first one to the second or the second one to the first. When I'm doing addition, it will always be the same answer. For example, 3 plus 2 equals 5, and also 2 plus 3 equals 5. It doesn't matter if I first add the 3 to the 2 or first add the 2 to the 3, they will be equal 5 the same. So this law, it applies to any two numbers in the world that I will choose. It will always be correct. That doesn't matter if I add the first one to the second or the second one to the first, it will always be the same result. So this kind of sentence that I'm saying, it applies to any two numbers in the world that I'm going to choose. And this is why you write it this way. We're talking about two numbers, and two of them can be any number that I please. Another time that we see two quantifiers one after the other is the following example. So now we are talking about, we see that we have a quantifier with the shape of the capital E, like looking at it in the mirror, and we have it twice, one after another. What does that mean? This means the following. It means that there exists a number, and to this number that exists, there is another number that exists. There exist two numbers. Two numbers exist. Maybe there's just one of each. Maybe multiple options. But we know that there are at least two numbers that exist. And what I'm going to say about the relationship of those two numbers to each other, what I'm going to say about x and y, will be true. And there is two numbers at least that one of them and the other one I'm choosing, and I can say that there is at least they exist, two numbers, this and the other, and I can say something about them, about the relationship between them, or about the relationship with other numbers, and it will be true, at least for those two numbers that I know that they exist. And I will give you an example. For example, I can say that I know that there are two numbers that exist, that if I add them to one another, I will get the number 5. And actually it's true, because I can take the numbers 1 and 4 and add them, and I get 5. And I can also take the numbers 2 and 3, I add them to one another, and I get 5. So I can see that it's true that they do exist. They do exist two numbers, and that if I add them to one another, I get the number 5. So this is when I want to say that I know that there are two numbers that exist that satisfy some kind of relationship or assertion or something that I'm saying about those two numbers. I know that there are two numbers that will satisfy my my assertion, what I want to say about those two numbers, x and y. So this is another example of two quantifiers that are following one another in a couple, in a dyad. Another way that we see two quantifiers that are coming together as a couple is if I have first the letter A on its head and then the letter E on its head, and I'll show you what I mean. So when we have first the letter A on its head and then the letter E on its head, we're talking about the following idea. When I'm saying that, and now I'm starting with this A here, when I'm saying that for every number in the world that I will choose, I'm still here in this opposite A, when I'm saying that for any number in the world that I will choose, I can say that regarding this number, there exists a number that, and then I can say something about the relationship between x and y, or something about their values or their behavior. And I will show you an example for what I mean. So I can say that for any number in the world that I will choose, for that number, and it can be any number that I please, exists some number, some other number, that if I add both of them together to one another, I will receive the number 100. And this is true. It doesn't matter which number I choose. Let's say I can choose any number I want. Let's say I'm choosing the number 3. For the number 3 that I chose, and I could have chosen any number in the world, for that number 3, there exists some number that if I will add it to the first one, I will get the number 100. And it's true. So I chose here, I could have chosen any number I want, but I chose the number 3. So for this number 3, if I add, there exists a number that if I will add it to it, I will get the number 100. That number that exists is the number 97. Because if I add 97 to 3, I will get 100. And this applies. I'll show you another example. If I'm choosing, now I can choose, now that I'm in the beginning, in this opposite A, this flipped A, I can choose any number I want. I will choose 103, but I could have chosen any number I want. I know for this number that I'm now choosing, and I could have chosen any number, for this number 103, there exists, maybe just one, yes, just one in this case, but there exists some number that if I will add it to the number I chose here, I will get the number 100. And the number that exists here is the number -3. Because if I will add -3 to the number I chose, 103, which could have been any number, I will get the number 100. So now we see how we have this couple, two quantifiers, one after another. The first one was A on its head, and the other one was this opposite E. And now I'll show you the last option of two quantifiers that are following one another. And the last example is this one. So what does this mean? This means, first we see that we have this opposite E, which means exists some number, and only then we have the opposite A, which means all number in the world. And I will give you an example how this is being manifested. So I can say the following. I can say that there is a number that exists, and you will guess very soon which number I'm talking about. I'm talking about a specific number. I know there exists a number, we're here in this E, this opposite E. I know there exists a number that regarding this number, no matter, now I'm jumping to the other side, to the side of the A. I'm saying to you, regarding this number, there exists a number that regarding him, regarding this number that exists, you will soon guess which number I'm talking about. Whichever number in the world, now I'm here, whichever number in the world I will choose, if I will multiply those two numbers one in another, I will receive 0. Do you know which number I'm talking about that exists here? You're correct. The number 0. Because regarding the number 0, and there exists a number that satisfies what I just said, that's the number 0. Whichever, now I'm here, whichever number in the world that I will choose, if I will multiply it with 0, I will receive 0. This number satisfies it. In the number 0, there exists such number. No matter which number in the world I will choose, this is the symbol of the quantifier A on its head. If I will multiply, now I'm saying something about the relationship between x and y. If I will multiply them one in each other, I will always receive 0. So this is how it manifests to have two quantifiers, one after the other. And I thank you for listening to this lesson.